Yeah, good afternoon. Now I am starting my second video of 30th 3 2020 unit impulse response of first order system. For the unit impulse input, RS should be 1, input should be 1, and the output of the system can be obtained as CS is 1 into 1 divided by TS plus 1. This can be equal to 1 by Ts plus 1. This can be written as 1 divided by T into S plus 1 by T. Taking the inverse Laplace transform for the above equations, we get C of t is equal to 1 by T e to the power of minus omega t. Now, C of t is equal to 1 by T e to the power of minus T by T, where small t greater than or equal to 0. The response curve is shown. If you know that if it is an exponential decaying expressions, so the maximum amplitude is 1 by T, and you can see that it will be exponentially decaying to 0. So this is the unit impulse response of the first order system. Now, what is the important property of linear time invariant system? The analysis of it has been shown that for a unit ramp input, output C of t is, we already come across that C of t is t minus t plus e to the power of minus t by t for t greater than or equal to 0. This is for a unit ramp input. For unit ramp input, you are getting an expression C of t is equal to t minus t plus small t minus capital T plus capital T into e to the power of minus t by t for t greater than or equal to 0. For the unit step input, which is the derivative of unit ramp input, the output C of t is 1 minus e to the power of minus t by capital T for t greater than 0. So here the unit step input is nothing but the unit ramp, the output of unit step input can be obtained by deriving the output of unit ramp input. Okay, so it is very much related to unit step input, that is derivative of the unit ramp input. Similarly, output also getting by deriving it with respect to t. Now the unit impulse, if you are using for unit impulse, which is the derivative of unit step input, the output C of t is equal to C of t is 1 by T e to the power of minus t by t for t greater than or equal to 0. Comparison of system response for these three input clearly indicate that the response of the derivative of the input signal can be obtained by differentiating the response of the system to the original signal. Response of the derivative of an input signal can be obtained by differentiating the response of the system to the original signal. It can also be seen that the response of the integral of the original signal can be obtained by integrating the response of the system to the original signal and by determining the integration constant from the zero output initial conditions. This is the property of linear time invariant system. So what you can see that we compared the unit ramp input, unit step input, unit impulse response. Unit step input is obtained by deriving unit ramp input. Unit impulse input is the derivative of unit step input. indicates that the response of the derivative of an input signal can be obtained by differentiating the response of the system to the original signal. So when you are deriving the unit ramp, you are getting unit step signal. If you are deriving unit ramp, you are getting unit step input. If you are deriving the response of the unit ramp, you will get the response of unit step input that is explained here. And if you go from this side to here, it is integration. Unit impulse response, if you are integrating unit impulse input, if you are integrating, you will get unit ramp input. If you are integrating unit impulse, if you are integrating, you will get a unit step. If you are integrating unit step, you will get a unit ramp input. Now, second order system. So here the second order system, all of you go through this. This is the second order system. Consider second order system because the closed loop transfer function of Cs by R of S is given by, it is the second order system Cs by Rs is equal to omega n square divided by S square plus 2 xi omega n S plus omega n square. So for the xi is the damping ratio and omega n is undamped natural frequency. So this is your transfer. Cs by Rs is this one. So here omega n square divided by S square plus 2 xi omega ns. And so the same way for a unity feedback circuit, you will get Cs by R of S is nothing but this term divided by, because here minus 1 plus this term into 1. When you are rearranging it, you are getting C of S by R of S is equal to omega n square divided by S square plus 2 xi omega ns plus omega n square. This is Cs by R of S is known as the standard form of second order system. The dynamic behavior of the second order system can be described by in terms of two parameters, xi and omega n. Now, if xi is equal to 0, the poles are purely imaginary and lies on the j omega axis. If xi is, what is xi? Xi is nothing but, as you can see that the xi is damping ratio. If xi is 0, the poles are purely imaginary and lie on the j omega axis. The system is then called undamped. The transient response does not die out. It is purely oscillatory. If xi is 0, the transient response does not die out. It is purely oscillatory. If xi is between 0 and 1, the closed loop poles are complex conjugate and lies in the left half of the S-plane. The system is then called underdamped and the transient response is oscillatory when xi is less than between 0 and 1. When xi is 0, system is called undamped. The transient response does not die out. It is purely oscillatory. And if xi is 1, the poles are real, negative and equal. The system is called critically damped the response rises slowly and reaches the final value. If psi is greater than, the poles are real, negative, and unequal, the system is called overdamped. The output rises towards its final value slowly. The critically damped and overdamped. Critically damped and overdamped. That means if psi is 1 and psi is greater than 1, system do not exhibit any overshoot. The time response of any system is characterized by roots of its denominator polynomial, which in fact are the poles in the transfer functions. Now, denominator polynomial QS is therefore called as characteristic polynomial. Q of S is equal to 0, and it is called characteristic equations. The characteristic equation of the system under consideration is whatever Cs by whatever therein Cs by R of S, whatever there in the denominator, when you are equating to this denominator equal to 0, that is known as characteristic equations. When you are equating it, you will get S square 2 psi omega ns plus omega n square is equal to 0. The root of this characteristic equation are given by S square plus 2 psi omega ns plus omega n square is given by S minus S1 and S minus S2. For psi less than 1, S1, S2 is equal to minus psi omega n plus or minus j omega n square root of 1 minus psi square. Then this is equal to minus psi omega n plus or minus j omega d, where omega d is equal to omega n, where omega d is equal to omega n square root of 1 minus psi square is called damped natural frequency. Most control systems with the equations of proprietary control systems are designed with the damping factor psi less than 1 to have a high response speed. So this is all important term. What is omega d? That is omega n square root of 1 minus psi square, and the roots when psi is less than 1, you are getting it as minus psi omega n plus or minus j omega d, S1 and S2 represented like that. Now, response of an underdamped system where the psi is between 0 and 1. In this case, C of S by R of S can be written as C of S by R of S is equal to omega n square divided by S square plus 2 psi omega ns plus omega n square is equal to omega n square plus S plus psi omega n plus j omega d, because denominator the roots we find it, that is previous case you found the roots, it is minus psi omega n plus or minus j omega d, S minus S1 into S minus S2. This form you have to write it under that. When you are writing that, you are getting this as S plus psi omega n plus j omega d, S plus psi omega n minus j omega d. For the unit step input, Rs is equal to 1 by S. Therefore, C of S is equal to omega n square divided by s into s square 2 psi omega ns plus omega n square, that is equal to 1 by s, 1 by s into 1 by s minus, we are rearranging this as 1 minus s plus 2 psi omega n divided by s square plus 2 psi omega ns plus omega n square. When you are if you are reducing these expressions, taking the common term, then you are getting the same expressions. We are splitting the expression into two terms. That is equal to 1 by s plus 2 psi omega n. Here again, this can be written as s plus 2 psi omega n all square. And whatever, when you are writing this, whatever the extra term, that should be compensated. So you are getting it as omega n square as it is. The extra term, that is mn square minus psi square, that is to be removed. Okay, so when there is s plus psi omega n all square is equal to s square plus 2 psi omega n, 2 psi omega n plus 2s psi omega n, then psi square omega n square. It is there. So yes, psi square omega n square, this term, you can see that this term is extra. That term should be subtracted. You can see that term should be subtracted when you're comparing. S square you are getting here. The second 2 psi omega ns, 2s psi omega n, 2 psi omega ns, that is when you are doing the second term of this square term. And the third term, that is psi square omega n square, that is to be subtracted omega n square as it is. Now 1 by s plus psi omega n divided by s plus psi omega n square plus omega d square. Omega n minus omega n square psi square is equal to omega, so that is equal to 1 by, yes, we are rearranging this expression properly, and you know that omega d is equal to omega n, omega d is equal to omega n square root of 1 minus psi square. Okay, so by using that you are modifying these expressions. 1 by s minus s plus 2 psi omega n is there. So what they are doing is, this term, they are splitting into in this form. So could you just try, all of you, how you are getting this? All of you look into these expressions. Ultimately, when you are doing like this omega d and this omega d will be cancelled. Okay, xi omega n here, denominator. Yeah, s plus xi omega n square plus omega d. Yeah, when you are taking the common term, so you will get the same expressions. Yeah, you will get the same expressions. All of you write it here, this one. So after that, omega n divided by omega d. Omega n divided by omega d, that is nothing but 1 divided by square root of 1 minus eta square. Here omega d by omega n, omega d by omega n. Yeah. Now omega n by omega d. When you are writing this, omega n by omega d is equal to omega n by omega d. This will come to this side. So 1 divided by square root of 1 minus eta square. So that is happening here. Eta as it is. But this one, square root of 1 minus eta square, how it is coming. And when you are taking these expressions, I am writing here, that is equal to 1 by s minus s plus xi omega n divided by s plus xi omega n all square plus omega d square minus xi divided by xi omega n divided by omega d into omega d by s. This can be written as s into s plus xi omega n all square plus omega d square. Omega d square, you know that what is omega d square? It is nothing but, omega d square is nothing but omega n square into 1 minus eta square. Omega d square is this. So what I want to say that we are modifying this one, omega n square minus, here when you are taking omega n square minus omega n square eta square, this you can write it as omega n square into 1 minus eta square. This is equal to omega d square. That is why this above expressions, all of you concentrate where I am showing, you concentrate here. This expression, this will become omega d square. So the above expression become 1 by s minus this expression. All of you concentrate this. First you will write this, then we will come to this. Okay. So 1 by s minus s plus 2 psi omega n divided by s plus psi omega n all square plus omega d square. This, what they are doing is, they are splitting 1 by s as it is. Then s plus 2 omega n is there. S minus s plus 2 omega n is there. That they are written s plus xi omega n, 2 xi omega n, they are written 1 xi omega n divided by s plus xi omega n all square plus omega d square. Here minus 10 minus, because another psi omega n into s plus xi omega n all square plus omega d with what they did is, here they multiply by omega d, here also they multiply by omega d. That is why happening here. You see that. That is this expressions. Now after that, what they did is omega d, omega n by omega d is 1 divided by square root of 1 minus eta square. Here omega n by omega d is there, that is psi divided by square root of 1 minus eta square. This as it is, here omega d divided by s plus psi omega n d plus omega d square. This is a standard form. Now when you are taking the Laplace transform, c of t become 1 minus e to the power of minus psi omega n t, this one, e to the power of, this is standard form. When you are taking the Laplace transform, this will become e to the power of psi omega n t into cos omega d t, this is a standard form, minus, this is a term psi divided by square root of 1 minus eta square as it is. Then omega d divided by s plus psi omega n square plus omega d is nothing but e to the power of psi omega n t into sin omega dt. This is also standard form, standard inverse Laplace transform. Now 1 by s become 1. Now what they did is, they have taken this one as 1 minus 1 minus e to the power of psi omega n d divided by 1 minus eta square, they are taken as constant, and here that is 1 minus eta square term is square root of 1 minus eta square term is dot there. That is why it is multiplied by the cos omega t dt plus xi omega dt. So it is not tough. If you go through it, you will understand. Now again, cos A, cos B, sin A, sin B, in that form they made it. So here, as you can see that the previous one, yeah, you concentrate here, this term square root of 1 minus eta square, and here xi, what they did is 1 minus e to the power of psi omega nt divided by square root of 1 minus eta square sin theta cos omega d t plus cos theta sin omega dt cos theta sin omega dt. So here, yes, how they are getting it, that form, when you go to the particular diagram, that will show this relationship, theta, there's a relationship between theta and xi. So cos theta means, yeah, as you can see that sin theta is nothing but, 1 minute, whether it is written correctly, yeah, sin theta is nothing but opposite side divided by hypotenuse. So you are getting square root of 1 minus eta square minus 1, that is cos theta. Psi divided by 1 is, no, this is sin theta is square root of 1 minus eta square by 1. Cos theta is xi by 1. So cos theta is xi, and sin theta is square root of 1 minus eta square by 1. So that is why, yeah, you are getting this term. So sin theta cos